Hi everybody and welcome to our webinar. My name is Daniela and I'm the Secondary Mathematics Education Consultant at Math. I'll be your host today. This webinar is titled Exploring Mathematical Reasoning in the Middle Years and will be presented by the wonderful Tom Moore. Most of you will have heard of Tom as he's been very active and a very active member in the maths education world recently. But if this is the first time you're seeing Tom present, I can assure you you're in for a treat. Tom is a really enthusiastic teacher, education consultant, and he owns his own maths education company called Engage Me Mathematics. On top of all of that, Tom's also in the process of completing his PhD. He truly loves what he does, and he was born to do what he does, and that passion always comes through when he presents. Matt is really lucky to work so closely with Tom on so many different projects, and I've been really lucky to be involved in those with Tom as well recently. Just a few housekeeping things before I pass over to our presenter. I have muted you all on entry. I can see some of you are unmuting yourselves already. Just going to mute you. There we go. Just please keep your mic muted throughout the presentation. There will be opportunities, I'm sure, Tom, you'll let me know soon as well, for them to unmute and contribute at certain times. Is that right?
Yes, that is correct. But yes. I'll let you know sort of one by one because we can't be having 144 people doing that.
We've got quite a large number of people registered for tonight, so we're expecting a lot of you. So maybe you won't all get a chance to have a say, but there will be opportunities. And if there isn't opportunities to speak verbally, you can always use the chat box, and we'll try to get to every one of you through that. Also, this webinar is being recorded, and you will receive the recording as well as any resources, including the slides that we will use today. So there's no need to frantically write anything down. You will receive all the resources. Okay, over to you, Tom. Good luck.
Okay, excellent. Thank you very much, Daniela, for that amazing intro. And if you wouldn't mind, could you just quickly type in the chat for people if they can't hear us to try logging in and then back out again? Hopefully we can sort of get on top of those audio issues for people. But thank you, firstly, for those amazing things that you said as you went through and did. I thought, wow, geez, I've got to live up to this now. So there is a bit of pressure, and I appreciate that because, you know, pressure makes diamonds. So hopefully that's what we'll go for today. Now, in terms of this, I'd also like to say thanks as well to everyone. I know that you guys are flat chat with your classes and remote learning and all of those things at the moment. So it's actually a real honor to be able to present to all of you today and to know that you guys have been willing to give up all, you know, the very little time that you have to be here today with us. So hopefully you'll get something out of this. I've tried to make sure that I brought a whole lot of resources and stuff in so that you can take something away. So hopefully you guys went through and had a bit of a go at the warm-up activity. If you didn't, though, it's not the be-all and end-all. It's just a great little reasoning activity that you can use with your students. And I've used that with students all the way up to year 11. And, you know, all it's involving is some simple addition, but there's some reasoning that goes into that makes it challenging and that makes it engaging. All right, let's get on with the presentation. So I'll just click on this. What I've got here on my screen are two images. Now, these images are located somewhere in the world, and I've zoomed right in on a certain place. And your challenge right now is to have a look at this and to try and figure out where in the world I am for these two places. But I'm going to give you, don't answer this before anyone, I'll give you about 10 seconds before you put it into the chat, but after 10 seconds, I'll let you know when, type in where you think it is. All right, have a look around. I'll give you 10 seconds. All right, a couple of people are pretty keen. You can now start entering in those answers. So if you think you know whereabouts we are, there we go. So I can see a number of people putting in Egypt, Africa, Madagascar, India. So let's now have a look at where we are for each one of these places. I'll just go ahead and we'll press play on this one. I'll zoom out and we'll have a look at where we are. Getting there. And of course, we are in India. All right, so for the next one, now, of course, with the India as well, there might have been a couple of hints in terms of you might have seen Taj written, or maybe you knew that Agra was part of India, where the Taj was. Let me show you this one. this one was a nice, easy one. I wanted to give you a little bit of information in terms of the seashells being around and Mozambique being there. So, of course, we were in Madagascar. Now, I'm going to come back to this and how it relates to reasoning in a second. But before we do that, I just want to get your thoughts on what mathematical reasoning is. So I've included all of the proficiencies here from the Victorian curriculum, and I've sort of highlighted the main sort of things that I got from them when I was reading through the proficiencies, but I'm interested to know what reasoning means to you. So feel free to put into the chat what reasoning is to you. So I've got Sushma saying language, making sense of, communicating your thinking, number sense, justifying, something makes sense, being able to understand and express your thoughts, describing your thinking, logical thinking, explaining your thinking, using facts, etc., proving your solutions. Awesome. All of these things you'll see when it comes to looking at the VCAA statement, you'll see all of these things come through. And in fact, I'll bring that up for you now. I'll give you a moment to sort of read that statement there. In fact, I'll read it out as you guys get the chance. So, reasoning refers to students developing an increasingly sophisticated capacity for logical, statistical, and probabilistic thinking and actions, such as conjecturing, hypothesizing, analyzing, proving, evaluating, explaining, inferring, justifying, refuting, abstracting, and generalizing. Geez, there's a lot there, isn't there? Students are reasoning mathematically when they explain their thinking, deduce and justify strategies used and conclusions reached, adapts the unknown to the known to the unknown, transfers learning from one context to another, proves that something is true or false, makes inferences about data or the likelihood of events, and compares and contrasts related ideas and explain their choices. Now, I probably went through that very quick for you, but it is all on the VCAA website, and you will have seen this no doubt before. But to me, reasoning is much like what we did in that first task where we started off looking at the map and we're trying to make sense of information that's around us in order to be able to take a step back and see the bigger picture, to make sense of the landscape that's around us, or in other words, I guess, to see the forest through the trees. Reasoning is that process of being able to look at things, muddle our way through it, and then be able to make sense of it in its bigger picture. And we do that through all of these different words or verbs, I guess you could say, that we can see up on the screen here. Now, you'll notice that, and so in terms of what I did when I went through and looked at the VCAA website, I just sort of put it down as these things. Now, there's more to it, but I just wanted to put it all on one nice plate. And you'll see that I've got the knife and the fork. And the reason why I do this is because I look at the proficiencies on the VCAA website as being sort of like the healthy, balanced, nutritious meal that we would give students in terms of mathematics learning. For example, if all we give them is fluency, they'll miss out on all the other stuff that is so important to knowing and understanding mathematics. And I'll tell you a little story as well. When I first started down this journey, I actually gave a lot of students, I've spent a lot of time on the reasoning side of things, and in fact, I neglected the understanding, fluency, and problem solving. Now, I love reasoning, and I think that's one of the most meaty parts of the meal. All right, reasoning to me is kind of like the hero on the plate. It's like your nonna's lasagna or your mum's Sunday roast. You know, it is the best. Okay. Oh, okay. I can see that I'm cutting in and out. Can people? Is that common for everyone? Can I just get it in the comments if I am cutting in and out? Okay, here. All right. So it might be some people. Thank you for that. If I am cutting in and out, you might need to just change your audio settings. But reasoning is part of the meal. Now, we can't just focus on reasoning, like we just can't focus on fluency. We have to have a nice, balanced, nutritional diet for our students. And when I did this, when I focused on reasoning, just reasoning, what happened was students pushed back because they needed that balance of all of the other proficiencies. So it is important to make sure that we're constantly looking at what we're teaching and thinking about, well, which proficiencies am I mainly addressing, and making sure we deliver a nice balanced curriculum in terms of working mathematically. Okay. So in terms of reasoning as well, I've read this book recently. It's by Tracy Zagar. It's Becoming the Maths Teacher You Wish You Had. And I really enjoyed this and highly recommend it to anyone else who's interested in reading something along these lines. It She described reasoning as being similar to writing for students. So when you go through and you write, like I know I write emails, and quite often I'll write the first little bit and then the next little bit, but then I'll try and change it around. So it's not quite a linear thing. In fact, it can be circular. It can come at it from different angles. So reasoning is about coming at things from different approaches, and it's not always linear. But what I find is when I work with students and when I work with schools, that this process doesn't happen all that often in the classes. And that's actually been backed up by some of the research that Di Seaman's done as well. And she said that activities involving mathematical reasoning are rarely given the attention that they deserve. So this is why I'm focusing, or I chose to focus on reasoning tonight, because I really think that this is an important area for us to work on as a profession. Now, that's not to say that doesn't happen in every classroom or that happens in every classroom, obviously, and the people that are here because they want to learn more, and they obviously value reasoning as well. So it's not to say it happens in every classroom, but it's an important thing to keep in the back of our minds. So, mathematical reasoning. This is the part where we're going to go and explore some tasks and have a bit of a fun when playing around with it. So mathematical reasoning I see as being a couple of different ways, all right? Mathematical reasoning for fun is one of the things I love most. So we're going to explore a couple of these. Here is an image that I came across on the internet, and it came from the website that you can see down below. And it actually inspired me to make my own as well. But my challenge for you is the white square that you can see here is equal to 1. That's 1 square unit. My challenge for you is to just, once again, don't write it straight away. Give yourself about 10, 15 seconds to have a look at it. And I'll tell you when that time's up. Have a look at it and try and put down what other colors you think you could figure out if we know that this white square is equal to 1. So I'll give you 15 seconds to go through and have a look. Awesome. Erin's just used that one today. Brilliant. So don't start writing anything in just yet, though. Give you 15 seconds to have a look. That's down to 10.
Tom, Jesse, will there be hyperlinks to the resources you've referenced by any chance? So I'm sure do you have a resources or a reference list at the end?
Yes, that absolutely. There's a reference list at the end, and you'll get access to these slides, so you'll be able to go through all those hyperlinks as well. Wonderful. Excellent. Now, feel free to type in what can we see? What do we notice in terms of colors? Has anyone got any thoughts in terms of what they think different colors might be worth if we know the square is 1? Cool. So the brown is 2. So that is this brown here. I can see 1, and then this one here. If we move this part over here, that'll be 2. In fact, I'm going to bring the pen. So if I got this brown part here and I moved it over there, I could see 2. Top right grey is 2. So the top right grey, or would that be the left one maybe? I can see here. So if I put this one down there and this part down here, I could see 2. Awesome. Blue equals 2. Oh, that's an interesting one. Who put down the blue was 2? Is someone able to, whoever put down the blue was 2, were you able to jump on the mic and share your thinking? All right, just while we wait for that. So I can see a whole lot of things. Now, what I'm interested in is as well as thinking...
Sorry, Tom?
No, that's right. Sorry, what was that?
Because I put down that the light blue in the top right is worth a half.
Okay, excellent. So you're talking about this one here?
Yep, and I think what they mean by the other blues is when you look at the white square.
The white square, so this one, yes.
Yep, hang on. So when you look at the white square and you look at the light blue on top and the light blue down the bottom, they're each worth 1. So together that would be 2. And the blue
so you're saying...
side are also each worth 1. So together they would be 2.
So you're saying if I put this one here down here, that therefore would be equal to 2. And what was your other thing that you just said, sorry?
The 2 blues on either side are the same.
Okay, awesome. So you can see here that and that would also equal 2. Yeah, nice. So, and we know, of course, if that part, all these blues, so if that's 2 and that's 2, that'll be 4, and then we've got the white here would be 5. So therefore we can figure out that that's the same as the brown, isn't it?
Yep.
Nice. Okay, very nice. All can solve. All right. Are we allowed to use formulas for areas as well? Well, absolutely. If you know stuff, then you certainly can use the formulas. But at the same time, it's good to use the reasoning in terms of, well, how else might we know? For example, how might I know that the yellow here, or how might I be able to figure out the yellow? Or how might I be able, if I know that, how could I figure out the orange? So it's a great way to not only be able to explain it in terms of you with formulas, but also if you can explain it in another way. My favorite one is this orange, sorry, the purple one here. Does anyone want to have a go at the purple one? Rainbow colors are all two. Okay. Simon, would you mind sharing your thinking for the purple one if you could just jump on the mic? Or M heating? Or heading, if that's how you say it, sorry.
Yep, I can see that. I haven't got a pen, so the one on
That's
the
okay.
bottom left, if you rotate the one above it down to fill in its hole on the top left corner of it, and then take the one that's second on the right down and swivel it down, you've got a full one there, and then you add in half of the top right cube.
Okay, so am I right in sort of saying you're using these 4 squares here
Yep.
to be able to figure it out? So you're figuring out that this one here, this one here, this one here, and this one here would equal 2.
Yes, and then I subtract.
This would be... Oh, yep, you go.
Yep, then take away that top corner.
Then take away the top corner. So you're going 4, subtract 2, subtract another half will then get us this part here, the purple one, which would be, of course, 1.5.
That way, and also just rotate the 2 smaller bottom purple sections to complete the one in the bottom left corner.
Oh, I like that. So you're saying if I got this part here and I moved that around to there, and if I got this part here and I moved that around to here, and that would make my 1, and then I got my 1/2 there. Ooh, nice. I really like that. All right, so this is the whole point, and this is what I mean in terms of fun. When I first came, maybe it's just me. Maybe I'm just one of those people that just get excited by colors, pretty colors, and bright lights. In fact, I am one of those people. But when it came to this, I saw it and I just went. I found myself spending the next 5 minutes going, "Ooh, what's this one equal?" And trying to figure my way through and nut them out. And there's always ones like this purple one that you could see here that really stood out to me. And this is what I mean in terms of mathematical reasoning is fun. All right, this is why I see it as being fun. I'm just going to go. Just going to remove this stuff off here, and we'll go to the next one. Another task that I've got in terms of mathematical reasoning is what you've got here is how many squares can you make on this using this here. Now I'm actually going to copy the links in. I'll go Command V. If you go to the first link that you can see on the screen, okay, the first link that you see on the screen, you'll see it's going to take you to. I'll share my other screen with you. You'll see it's going to you to. I'm just going to get to the right part. Okay. So hopefully we can all see that now. You'll see it'll take you to this now. What you can do is you can come down to the bottom part of this screen here, and you'll see that there's another arrow or an arrow that will take you to the next part. This will bring you to your dots there. So you can have a play around with it. I'm interested to know how many squares can you make on this actual screen. So have a play around with it for the next couple of minutes and see how many you can find. Feel free to put it in the chat once you've found out or once you think you've got the answer. Okay, I've got a couple people going 30. Michael, would you? Oh, okay. So Michael said 30, and then he's retracted that. Now I've got Eleanor. So and Hong is saying more than 30. Michael, could you share what your thinking is when you saying retract 30?
Oh, can you hear me?
Yes, I can hear.
I originally thought 30 based on the squares that are based on vertical and horizontal lines, but then have realised there's also squares that are orientated diagonally.
So you're saying you can rotate the square, so a square is still a square if you rotate it.
Yes.
Yeah, nice. Okay. Awesome. All right. Well, then I'll leave you guys to have a bit of a play around with it. Let's see how many we can find there. And think about, as you're doing this, the process, the muddling that you're going through in order to be able to find them all. And if you think you come up with another answer, feel free to put it into the chat as well, whilst I try and figure out how to move all my screen around. Okay, so what Michael was saying before was obviously a square is still a square if we rotate it. So, I mean, that's a terrible attempt at a square, but you get the idea. If I rotate it around, so there's more than the normal thing that we would lay out. Okay, so now we're getting up to 42 and 40. Are there more? Because that's the thing, is once we start to get to the point where we think we've got them, it's now a matter of making sure that we're 100% sure that there's actually 40. So are there in fact more? So Simon's saying 25 or 25 factorial, which 25 factorial will be a lot. Or is he saying 25? So what is it? I can see Jodie's got her 42. Oh, okay. Prathu's saying you could also have squares which are tilted at 60 degrees. And what about overlay? So I guess, for example, in terms of asking the overlay stuff, this here is still another square. You can still make another square using that. But you've got one square here. You've got the one square that we've got here, and then we've got another square that's over the top of that. So that's two squares. So you can have ones which overlay, but obviously you can't have ones which go directly on top. For example, if I did one square here and then another one straight on top of that, that's the same square. So probably not. Then the square in the middle there. Oh, no, I got what you're saying now. So with the square in particular, it's got to be sort of the ones that it's on, like on a geo board. If you had a rubber band and you put a rubber band around the geo board, how would you make those squares? Great question. So yes, they need to go through the dots. Great point. All right, so I can see, can we see as we're going through this, some of the reasoning that's coming through? Oh, Michael's now come up with 56. So we're now getting more and more, aren't we? The challenge now, and what about overlays of different dimensions? Now we're talking about things like real mathematical reasoning. So we're taking things further. So once we've got all of them, and we know we've got all of them, and that goes through the reasoning process, you might start to think, okay, well, what happens if I then add other dimensions? So maybe what happens if I had a 5 by 6 or a 6 by 6? What happens if I did the square from overlapping structures? What could happen there? There is so much that could be explored in this. Prathu's saying that there's 50. All right. So we're now starting to get to a point where we could really go through and explore it more. Xavier's saying 50 as well. So Prathu and Xavier are both saying 50. Ruth's saying 56. We've got a whole lot of different answers coming through right now, which is really cool. Now, I'm not going to actually tell you the answer. I'd love for you to go through and explore it, because as soon as I give you the answer when it comes to mathematical reasoning, I've taken away all the fun. Hopefully at this point, what you're noticing is this investment. Like I said, mathematical reasoning is like, it's the hero on the plate. It's the chunky bit that you want to stick your teeth into and just have a go at. That's the stuff. And as soon as I tell you what the answer is, that kind of removes it for you, especially if you're trying to work through it. So it's about going through and trying to figure out and know that you've got them all, and do that in a way that makes sense. So I'm sorry, but I'm not going to give you the answer today. All right, I'm going to bring it back to the next part of the presentation because we're going to spend the next half an hour talking about another part of mathematical reasoning that I think is important. So bear with me a second whilst I get my screen up and running. If you want, feel free to have a go at still doing this whilst I do it. Would some students engage better with finding the different sizes and orientations rather than just the final number? Maybe, absolutely. And so you've got to, this is part of the agency with students, isn't it? You know, if we can allow them to have the opportunity to go off and explore a particular thing that they're interested in, are they still working mathematically? Are they still reasoning? Absolutely. So that's probably the goal or the learning intention or the goal that I would have for the lesson is, are students doing this? Are they reasoning? Are they working mathematically? And if they are, it doesn't matter how they're going about doing it. They don't have to answer our question that we put out to them. They can answer their own question. And we should encourage that more, because the more we do that, the more students will see mathematics as being something that's a creative endeavor rather than something that we just force down their throats, which you know, we don't want to do, but at times that students can perceive it that way. So awesome. Feel free to put all the other adaptations and stuff that you could see in here. I'm loving some of the chat. So from Daniela, like what are the number of rectangles and all that kind of thing, triangles. Feel free to put other adaptations in here whilst I sort out my screen. I will try and do that now. Okay, so we should be seeing my PowerPoint screen again, and I'll bring this up here. Okay, bear with me last couple of seconds. Now, can I just confirm that people are able to see my PowerPoint screen as well, just whilst I'm looking at the chat? Yes, thank you very much. And awesome. Thank you so much for that. So I love as well all of these different ideas in terms of taking it further. Is there a rule that you can find so that you know, if you know the dimensions on the dot grid, you'll know the squares right away? Wow, what a great generalization kind of thing that you could go through and do. My mentor once told me that a student thinking about their subject and the applications of it whilst at work or sport was just as valuable as them completing the practice questions. Yeah, absolutely. Absolutely. Thank you for sharing that. All right, let's go through. And so these are the kind of tasks that I could do all day long, and we could really go in and explore and pull them apart. And in fact, there's a great group of people, maths teacher circles, which I highly recommend people look them up on Facebook. And it's run by Michaela Epstein and Alex Box, who I believe we've got Alex with us today. They run this PD for teachers, and it's really cheap. It's if you're a member of Maths Teacher Circles, it's $5, and you go through and you just explore these tasks as a team and really pull them apart, and it's really, really great. So I highly recommend you you have a look at that stuff. Okay, I'm just going to climb that. Cool. So next one. These are great resources that you can use for that type of task, the rich, open-ended ones that you can explore. And you can go through and explore these at your own pace. You could spend days looking through all of these. But I often get asked the question, and this is a very fair thing, is, you know, that's great, Tom. These tasks are absolutely brilliant, but when are we going to get to do these with all the other curriculum constraints? You know, we've got to get through all these other things. You know, how can we actually bring reasoning in? Because we just don't have time to do all that stuff. And to be honest, like those tasks, I think we need to make time for. You know, it doesn't need to be every lesson by any means, but if we could work on maybe one of those a fortnight at the minimum, that'd be really great for our students. But in saying that, we can still bring reasoning in to our other into our other lessons. And this is what I'm sort of looking at. So we have reasoning for fun, for the sake of just enjoying maths and experiencing maths. But now we're going to explore some different question structures that you could use in your classes to address the content descriptors that use reasoning. All right, and I'll share some of these with you. Now, if you've seen some of my stuff on Engage Me Mathematics, you'll notice that we'll seen some of these animations. But when the whole purpose of these animations is, I ask the question of students, what's happening here? Now, I'm going to ask you the same question. So have a look through them and just feel free. I mean, you as teachers will probably be able to pick up pretty quickly, but what is actually happening in this animation? What is it showing us? And thank you, Savita. I really appreciate the feedback on that too. So what is this animation showing us? Feel free to put it in the chat. Cool. The area of a parallelogram is equal to the base times the height, or the area of the parallelogram is equal to the same as a rectangle, right? So just this reason here, we can go, okay, well, I can see what's happening, and therefore, if I know the area of a rectangle, which most students can figure out because we've worked with arrays and things going through primary school, I can then figure out the area of a parallelogram, that we can figure out the area of a parallelogram using what we know. Awesome. Now, using this information, let's take it one step further. I'm going to ask you, what's happening here? And this one, so this is building on what we've just done one step further. So what's happening here? Okay, so it's half of a rectangle, because we know it's half of a rectangle because it's half of a parallelogram, don't we? So it's creating a parallelogram. So 2 equal trapeziums are equal to 1 parallelogram. And 1 trapezium is half a parallelogram. Okay, would anyone maybe like to have a go at how we could use this diagram, or what's happening here? Oh, okay, so now I'm seeing demonstrates trapezium formula for area. Shows where the a plus b comes from, right? So if we think about this, the trapezium, the area for a trapezium is, the formula would actually be, in fact, I'll write it down here. Okay, pen. The formula for a trapezium is area equals, and it's half of a plus b times the height. Now, let's just make some sense of this, because I know that this isn't actually something that I knew off the top of my head when I started teaching. In fact, it took me a good few years before I actually went, oh, that makes sense. And it wasn't until just last year that I saw it in terms of what we're looking at now. So let's have a look at this. We know that the base of this parallelogram would be a plus b, because I know that this is b, and my a, of course, comes from this part here, doesn't it? All right. So now if I know that, and I know my height, well, that'll be like saying a plus b times the height will give us the parallelogram, but I only need half of it. So therefore, I've got this here. And I've actually made another one recently where it shows the same thing, but using 2 triangles. For example, you can see here, if I drew a triangle going down there, the same kind of stuff. And awesome, it's got tessellation. So all of these things come through, but the best part about this kind of question that I'm finding is by asking the students what's happening here, what I get is not necessarily always what I want, but it tells me what they do know, and it gives me an idea of where I can start focusing my teaching with the students in that lesson. So sometimes it might be taking it a step back. Sometimes it might be going, okay, I know these kids know a bit about it already, so they can go off and do a few more extended kind of questions, whereas these students are probably going to need to do a bit of work around the formula and understanding how that works too. So it really is a great way of opening up this question. And the other thing is, it's sort of like a bit of a challenge. It's a bit of like a secret. Hey, can you figure out what's going on here and let them tell us, rather than us just, like I said before, just telling them. It gets them to try and come up with themselves. So let me just remove this again, and I'll go on to the next one. The next what's happening here, and I won't spend too much more time, but I do want to show you 2 more of these things. I want to put this one up here, and I'm going to take it to the next level as well. So have a look at this and just figure out what's happening in this animation. The area model, cool. Now, some people will obviously look at this and be like, yep, I can see the area model straight away, the partitioning. Yeah, awesome. Allison's saying she used it with her grade 5s. That's brilliant, right? The box method, distributive law. Geez, there's so many things coming in here. Now, we're all talking in terms of what teachers would say and all that kind of thing. But when I showed this one to a year 11 student, it was amazing just seeing the penny drop for them. They went, oh, now I can see how the formula comes about. And what I like to do is, especially for students, once they've seen this and the formula, I would normally start off with this, by the way, but once students have seen this and the formula, I like to get them to compare the two and see, well, what's actually happening? How does this here relate to the formula that you might have seen? Now, in saying that, we can now see it in terms of another way, and this is probably for the sake of the primary teachers looking at, well, why is what you're doing there important for this? All right, so what is happening here? Cool. So now we've got we're now saying so you can, and hopefully Nadia, you can see that what you were doing with the primary students 5 is actually really relevant to year 9 binomial products and things like that. This is why it's so important to focus. We can teach binomials in a way that actually makes sense visually and get them to understand this. Now, I know when I ask you guys this question, what's happening here, it's probably quite easy for you to figure out. But when students look at this, there's an element of reasoning and thinking that goes on that really helps out with this. Matthew C does. Yeah, absolutely. It certainly can go up to year 11. In fact, you can use this same model to go through and factorize, and that's one of the animations that I'll get to at some point in time. I haven't made one yet about that, but certainly can. You can use this for factorizing, for completing the square. There's so much you can do with just using this model, and it all starts out with arrays back in primary school. So it's really helpful to go through and use that and build on. All right, and yeah, that helps with the students to see those connections and build those ones in too. So the next one is, I'm just going to have a look at the time here. Just bear with me a second because I don't want to go over. There we go. So another kind of question that's really, and this comes from visual patterns, is, what's happening here? And you don't even have to have animations. You could just put up some patterns and ask people what's happening here. So would anyone want to have a go? Just put down in the comments, what can you see actually happening? How do you see this growing? And if you'd like, have a go at maybe what the 10th one would look like. So that's this is image 1 up the top, image 2 on the second one. How do you see it growing? And how many would the 10th have in it? I'll give you a couple of seconds to go through, think about it, put your answers in. Okay, so expanding by 1 on each end. So every time we're sort of putting on an extra one here. Awesome. All the 3 times table. So I assume that that's for the first one, the 3 times table. Now I've deliberately put in one here that's probably aimed at your grade 5 kind of thing, and then I've put one here that's probably aimed at your year 8, 9 sort of thing as well. So 31 for the n. And okay, I can see 3n plus 1. So now we're starting to talk about it in terms of abstractly, in terms of algebra, because we can see if this here is my third, well, it's kind of saying, well, it's going to be, there we go, I've got an n here, an n here, and an n here. So therefore, it's like saying 3 times 3 plus 1. Whereas here, well, my n is 4. My n is 4. My n is 4. So that'd be like saying 3 times 4 plus 1. Okay, cool. And then if I had 10 on this arm, it would be like saying 3 times 10 plus 1. So therefore, that would be 31. There might be another way to look at it though too. For example, I might see it as being like this. Okay. So in this case, that might be 2n plus n plus 1. Can anyone see? Can we see how I've come about that? So that'd be 2 n's because that's my second one, and then I've got an n plus 1 here, which of course would be 3n plus 1 again, but there's different ways that we could go through and see this. And the reasoning is the process of going, once again, it's from looking at this information to taking a step back and going, I can see how all of these connect together. Oh, cool. Jeremy, so you're going n plus 2n. Can I get you, Jeremy, to jump on the mic and share your thinking with that? Because that sounds exciting. And you're right, Barbara. Yeah, absolutely. It allows for simplification, to discuss simplifying. Are you happy to share, Jeremy? All right, we may move on. So with this, did anyone see what's sort of happening in this bottom one? This one's harder. This one's a fair bit harder. Does anyone want to have a go? That's all right. Thanks, Jeremy. I appreciate you sharing your things there anyway. So does anyone want to have a go at what they can see going on in this bottom one? It is a bit harder. Square numbers minus sum, building in sevens. It's a mirror image diagonally. Cool. Oh, that's, yeah. So now we've kind of got, going across the y equals negative x line kind of thing there, isn't it? So we've got about symmetry. That's the one that I'm looking for. Yeah, great. So see, we don't even need to, we can explore it in any way we like, but this is, when I ask the question, what's happening here, it draws out a whole lot of information. All right. I might share with you how I see it, and we'll see and I'll share my reasoning behind it. It's hard to get that from the chats when we're hearing this, but I can see some square numbers coming in here. So for example, this here is my second and this here is my third. So I'm going to use the numbers 2 and 3 in order to be able to do this. Now Lane's looking at some things here as well. So I can see when I do this, I look at maybe a square number here, a 2 by 2, and you can see here that when it goes to 3, it becomes a 3 by 3. And in fact, I can see 2 of those. So I could see 2x squared going on here. All right, because my 2 squared, my 3 squared. Plus, then I can also see, well, here is an x, because that's a 3 and that's a 3. And then we can see here that's a 2 and that's a 2. So for whatever shape it is, you can see that sort of going on. So I can see 2 x's, and then I can also see 1, 2, and 3. So plus 3. Now, obviously, I've just gone through and shared that with you. And in fact, if you have a look at Lane's, what Lane's come up with is most likely going to come out as being the same thing, obviously interchanging the n's for x's. Hopefully, though, when I went through and demonstrated what I saw there, you could see my reasoning and how that came about. And if we can get students to do this, if we can get students to share their reasoning and make math social and get them to talk about these things that they can see, then hopefully that'll help other people in the class to be able to understand where they're coming from. And what would be even better, we don't have time to do it right now, sorry, but if Lane shared hers, we could then look at Lane's, and then we could look at, well, how do the two relate? How do they come together? And that once again comes through simplifying. So there's so much that you can do here with these visualpatterns.org. All right, so I'm just going to get out of this. Cool, and we'll go on to the next page. Another type of question that you can use. So we've looked at what's happening here as a really good way to develop reasoning. Another kind of approach that we could use to develop reasoning is a compare the pair, like the industry super fund. Right? You can put in a question that is addressing anything you like what you can see here, and get students to compare, well, which one's correct, which one's incorrect, how might they got their answers, what might the misconceptions be, and pull apart the answers that way. And in fact, this here, I would argue, if you have one of these kind of questions, you get more from students in spending a whole lesson on one of these questions than you would by getting them to do a whole bunch of similar questions that are just the same kind of thing over and over again. The reason that comes from it is really, really helpful for both us as teachers to be able to look at, okay, well, this is where our students are thinking at, and then for them to be able to work together as well. All right. Is there anyone here any one of these questions that stands out to anyone that we'd like to have a look at? Philip explained, I think I liked, actually, let's have a look at this one. Tracy says you can reduce 8/10 to 4/5. Dan says they are the same, but Tracy says 8/10 is larger. Who is right and how do you know? Okay. Yeah, so these are great because they address misconceptions. Agree entirely. So think about, as we read this, a good way to do this is actually to have a think about how students might answer it. And I really like that one too, the last one as well, Michael. Have a think about how students might answer these questions. So when you look at that, let's have a look at the last one. How do you reckon students might go about answering it? What are the different strategies that they might go to answer this and prove it? All right, feel free to put that in the chat, because so drawing, absolutely. I can see students going through and drawing these different ways. Drawing, paper folding, cool. So when making a model, we could do that. Paper folding, drawing, yep. Some students might just, finding a common multiple, absolutely. Some students might do that. So there's a whole range of things. What I saw, I was working with a teacher who, as part of my research, and short division, cool. I was working with a teacher who, as part of my research, and what she did was she walked around and took notice of how different people were solving it, and then she grouped them according to their strategy, And at the end of the lesson, or towards the end of the lesson, she got the groups to come up and share their strategy with the rest of the class. So they all saw it from different ways. I thought it was just such a great way to go through and attempt one of these questions. It was one question for the whole lesson, but what came from that was just such deep understanding about what was going on. Another approach that we could use is, and I have students that would say it's just the same. Yeah, great. And that's the process, I guess, of trying to then bring in that reasoning as well. So there's it's about going, okay, well, tell us why. Can you show us? Can you show us another way? So another strategy that we could use is always, sometimes, never. So I've just got a couple of these ones up. So square root of a number is less than or equal to that number. Right angles, a pentagon has fewer right angles than a rectangle. Area and perimeter, when you cut a piece of a shape, you reduce its perimeter and area. So with these questions, are they always, sometimes, or never true? I don't know about you guys, but when I came across these questions, I thought, oh my gosh, everything started running through my mind. And yeah, I can see people going, love it, wow. It's just so powerful to start thinking about things deeper rather than just saying, a square root, it gets less, but then does it, when you go less than 1, it doesn't always happen. So it's better for them to think about it before. Have you used always, sometimes, never for number talks and remote learning? Yeah, brilliant, awesome. Enrich, yeah, these ones, Enrich does have a number of them, absolutely. So I'm just looking at the time. Great, we're traveling along nicely. Another one that I quite like is the would you rather. Now, this one comes from America, but this website is based in America. So it's a little bit interesting because you got pizzas here, but then they talk about it as being pies, and that might be a bit confusing for students. But imagine that you went with 3 friends to go get pizza, and this was what was on offer. The question is, would you rather actually buy the 3 pizzas on separate, bills? So would you rather just go, I'll get one, you get one, and you get another? Or would you rather get all 3 pizzas on the same bill and split the bill once you've done that? Have a think about that as you go through and do that. And then how would you prove that that's the case? It's this, once again, it's the reasoning that comes through here. It's the thinking about, okay, well, I think this, but why do I think it? All right. So what would we rather? Would you rather option A or option B? And why? Feel free to put that into the chat as well. Option B. And why is that, Jeremy? Feel free to, because that's the whole point with this. And I know it's quick to put down the B. I'm actually asking for a lot in terms of chatting, but yeah, it's all about reasoning. So it's not just giving the answer, but why would you do it? B, you will receive a discount which is shared amongst all 3 of you. Okay, cool. Sarah, would you be able to jump on the mic and share your thinking a bit more about that, if that's all right?
Yeah, sure. If you all order your pizzas separately, then you'll all pay full price. But if you all order the pizzas together, then you'll get your 30% off. And then when you separate, divvy up the price, then you've all essentially taken part of the 30% discount.
Okay, can you give me maybe a bit more information, maybe with some numbers or something like that?
Oh gosh, it's the end of the day. I don't use my brain that much.
That's okay. I'll let you off to it right now. That's okay. But is there someone else who maybe would be able to share? So depends on if there's 3 multiple buy discount. All of them are the same price. So maybe they're not all the same price. Oh yeah, so jump in. Someone was just about to say something.
Yeah, so if you order one pie or pizza or whatever, so if one person orders that, they get the 10% off. So if the pizzas were $10, each person would pay $7 for their pizza. But if they went in and they got 20% off for 2 pizzas, then are they not just getting 20% off the total price, which is going to be the same discount anyway? And then I suppose then the question would be, when you divvy it up between each person, would they get then less? Which is, yeah, because for instance, if they got 3 pizzas, which was $30, and then they got a discount of $9, they'd have 21 to pay, but each person would still pay $7 each.
Ah, okay. So if you're saying that this one here down the bottom would be $7 per pizza.
Yeah.
Whereas
yep. Whereas the
if we
10% off, they have to pay $9 each if the pizza was $10.
Right, cool. I
Yeah,
like that. So
they'd have $9 each or $8 each, but then if they all got 3, they'd pay $7 each.
yeah, nice, absolutely, and that's so true. And then we could start thinking about, okay, well, we've now done it in terms of $10 because that's a nice round number, and that's a great place for people to start. But could we then do it in terms of algebraically? Like, how might we represent what's actually happening here in terms of with algebra? Like, there's a bit more going on here. I'd be more concerned about ordering pizzas from a pie shop. That's fair, Simon. I probably would be too. I guess this is what the Americans do. But yeah, I would be the same. All right, but we'll leave it there because I want to go on with the next one. We'll go on with the last little bit. So resources for hooks involving reasoning. So hopefully what you saw in that last little bit was us going through and it was really addressing, okay, well, we can't always do the fun, rich, open-ended maths lessons because we do have to address the curriculum. But hopefully you saw in those strategies that we just went through, and I'll share them with you again in a second, is these strategies help you to address the curriculum dot points, but also bring in reasoning at the same time. All right, how am I going for time? I might skip through this bit here, and I'll come back and just do a bit of a recap, and then I'll leave it open for questions for the next 5 minutes if you guys have got any, and I'll be more than happy to share my thinking and things along those lines. So, a little bit of a recap. At the very beginning of this workshop, we went through and had a bit of a look at, well, what is mathematical reasoning? What does it involve and all those things? And I talked about in terms of, the verbs of what it actually involves. But like I said, it really is looking at something and not being able to see the forest through the trees initially, but then as you make sense of the data and what's going on, it's about taking a step back and being able to try and make sense of that and see the broader picture. And we do that through doing each one of these verbs and being able to explain it to others. It's the bit, like I said before, it's the meaty part of the meal. It's the stuff that keeps us coming back for more. It's the exciting part of mathematics that I don't believe the other ones necessarily involve just as much. But maybe that's just my preference. I can't comment on that for everyone. These are some of the strategies that you can use to incorporate mathematical reasoning within our actual lessons. So number talks, mathematical exploration, so like rich tasks and things like that. And then the what's happening here, compare the pair, always, sometimes, never, would you rather. Those are the ones that I use to go through and actually explore, with specific content descriptors. Awesome. Alex Box, I've number talks, they changed my life. That is one hell of a pump up for number talks. It is awesome. It's so good. Okay, so yes, reasoning it's an important part though of the curriculum and what we do, but we need to make sure, like I said, that we address the entire plate, the entire nutritional meal that is maths education, because if we focus on just reasoning, it can turn students off as well. So really making sure that when we look at the tasks that we teach, think about them and reflect on them and think, well, what am I actually addressing in here? And am I focusing too much on understanding or fluency or problem solving or even reasoning? And do I need to make sure I'm addressing other parts of the meal that we need to do in terms of the proficiencies? Now, why is it important? I'll finish on this. So a couple of months ago, I came across a post that was from a fellow maths educator, absolute legend, and she put this up. And she shared this stat along with some of the data here. So I'm going to give you a moment to go through and have a look at what you can see here. Try and make sense of it. There's a lot there to take on. And then have a look at what one of the replies was from someone as well. So I'll give you oh yeah, and which one does it belong? Great one. I can't believe I didn't remember to put that one on. Have a look there though and try and make sense of what's actually going on in this post on Facebook. Oh, okay, it might be, yeah, all right, fair enough. It might be a little bit too hard for people to read. That's fair. Okay, so I'll just quickly summarize. What was happening is essentially there are two, oh, okay, cool. So Sarah said the first post was talking about daily tests, not overall tests, and the impact on an increase in rising cases. So essentially what's sort of happening is there was a post that was on Facebook, and the person who posted it talked about, okay, well, we had more tests done in Victoria than in New South Wales. So because there was more tests done, we were more likely to pick up on people who actually had coronavirus, because obviously we're doing more tests. But then the other person came through and said, no, there hasn't been more tests done in Victoria. There's been more tests done in New South Wales. Now, in fact, both were correct, but they were both arguing different things. And when the person who originally posted it went through and did this, they and the other person kept coming back. They explained their thinking, but the other person was so stuck on their data because they didn't. I would argue that they didn't quite get what was happening in the first piece of information. Now, why is this important? Well, especially right now when we're looking at people who need, people need to be able to read and interpret and make sense of a whole lot of facts and figures that are being thrown at them. And if we don't teach people to be able to reason and to be able to look through things and see, like I said, the forest through the trees, then we run that risk of people not really making sense of what's going on. And you're right. And some people, like it says, we need to define the population. So we could have certainly gone through and maybe define some things a bit better in the first instance, but then they did do that later on in the post. But it really is a matter of, okay, explaining the reasoning and really understanding what's going on. If we can't teach or if our students can't reason, then we run the risk of having these issues that people don't understand what's actually being put in front of them. And we know now more than ever that that's really, really important. So here are some final resources and this is everything that I've gone through today. It's all on the one slide. So you can go there at the end and do that. And also, I would really love your feedback on what you thought of today. Please feel free to give me constructive criticism, like anything that I can improve on, because I'm really passionate about getting better in what I do. So I would really love any kind of feedback along those lines. But other than that, thank you very much. If you've got questions, feel free to put them into the chat. I'm more than happy to go through and answer these for the last few minutes or the last couple of minutes. But also, yeah, like I said, thank you so much for your time today, because I know that, like I said, you're busy people, and for you to spend an hour here listening to me, it really is a pleasure to be with you guys today. Thank you. The green textbook in the Mylands was, I'll put a link to it. Let me find it. It's this one. Teaching Mathematics Foundations to Middle Years. That's the green textbook.
So what was it called? Sorry, Tom.
It was Teaching Mathematics.
Yeah.
Foundations to Middle Years.
Awesome. Thank you.
No worries. Now the chat's moving very quick, so if you've got other questions, feel free to chuck them in again, and I'll go through and answer them if I miss it. Do you think reasoning work suggests students are working at above standard as per Vic Fells? That's an interesting question. So reasoning type work suggests students are working at above standard. It depends on what type of reasoning we're giving. For example, you might have seen that very first task where we went through and did the Kenken, if you saw that at the very beginning. I wouldn't say that they're working at above the standard, because we're giving them tasks that's reasoning, but at a lower level in terms of skills. So you've got to look at the skill that you're developing or you're getting them to do, as well as the reasoning. And if the reasoning is just getting them to the point where they're understanding that skill, then I would say no, they're actually working at that standard. So you've got to think about, well, what are they doing with the skill? Are they taking it further, or are they just getting up to understanding that skill? How is the reasoning being used? Hopefully that answers your question. Okay, Savita, in terms of the Facebook animations, yes, so very exciting stuff. You at the moment there is an opportunity for you can go through and subscribe to my mailing list. If you look at any of the animations on the Facebook page, by subscribe, you'll find that there's a link to subscribe to my mailing list. You can do that. At the moment, though, the exciting part is we're actually in the process of putting together a website that people can subscribe to. And hopefully that'll be ready in the next month or two. We're in the process now. We've got someone, and hopefully we'll get that up and running really soon. So they're not in a place where everyone can get to them all at once just yet, but we will get to that point soon. So I'm sorry for it taking a little bit longer than what I would have liked. So the Engage Me Maths animations at the moment are only on Facebook, but you can still subscribe to our mailing list for free. And I send out our latest animations each week. the latest, we will have a website up and running in the next, like I said, month or two. Where will the slides be available? At the end of this, they'll be emailed through to you. Do you do much with Craig Barton? I'm reading his book now. I wish I'd taught maths. You know what? I've heard about Craig Barton. I haven't looked at too much of his stuff, but it's on my list of things to do. Do you think we can address all of the curriculum if we focus on the proficiencies? Emma, great question. Really great question. And yes, I do. But we've got to be clever in terms of how we go through and do it. So I would start off by doing a bit of an audit, or just keeping track roughly by looking at the curriculum and saying, okay, well, what is this activity that I've just done here? What is that actually doing? What am I addressing? Am I addressing fluency? Am I addressing understanding? Like, what are the main things that I'm doing? And maybe only choose the 2 ones that you do most. Most often students will address all in some capacity, but think, well, what is the one that, how am I, like in the way that I'm addressing this activity now, what is it most addressing? And then do that for a few activities over the space of a couple of weeks and just keep an audit of what's going on, and you'll get a very quick idea of what you're spending most of your time on. I really believe that it is possible. You can ask one question, and change the proficiency that you're addressing by changing the way in which you ask that question. And maybe that's a PD for me to do another time, but it's absolutely possible. Where do you access the mailing list? Okay, great question, Raylene. If you go to my Facebook page, I don't have the link. Sorry I should have put that one in. Sorry, but if you go to www.facebook.com/engage-me-mathematics, I'm just putting in this now, mathematics. You'll be able to find in any one of my latest animations. If you scroll through the comments, you'll see that there's actually a list of, like, there's a place where you can subscribe to it there. It's a bit of a workaround. I'm sorry to get you there. But yeah, that's the best way to do it. How do these tasks go during remote? Does that rich conversation go? Oh, great question. I think that, in fact, I have taught remotely recently because I'm doing my PhD and all that kind of thing at the moment. So I don't actually get to do that all. I don't get to teach remotely all that much at the moment, but I did get the opportunity to do it for 6 weeks during the first period of remote learning. And I think that there's a real opportunity for it, just like we've done today with using the chat function. And you've got to set up like class dynamics in doing so, but using the chat function, getting people to share and setting that expectation, and then having the breakout rooms. And what I use is ORAP. So what I have is students work together on this whiteboard, and I can just tab between the different whiteboards that they're collaborating on to see what they're doing, and that then sort of helps me to target, well, what breakout rooms am I going to go into? Is it as good as working in person? Absolutely not, but it is still possible to do.